Hey guys, today's going to be all talking. We're going to talk about what is a forge, the different parts of a forge, and the parts that you need to focus on. So of course the first part of a forge is the shell. The shell really isn't all that important. Shells can be anything from steel to brick and mortar to I've seen some people take a piece of baling wire and wrap it around their ceramic blanket. I don't recommend doing that, by the way. It is not safe. But the only thing a shell has to do is hold the guts of your forge in place. That's its only job. Now, I do recommend that you make your shell from something that is weld safe, because there's a lot of heat that's going to be escaping, and you don't want zinc letting off from galvanized materials or things melting, any of that. So be sure you use weld safe. The other thing I recommend to make sure that you go to at least 20 gauge thickness, if not thicker. The reason I recommend the 20 gauge is at that point you can start doing some spot welds to get little add-ons put onto your forge if you want. If you want to weld on a holder to keep your fuel line out of the way, things like that. The next part is where it's important and where you need to actually focus things, and that's the guts of the forge, which is going to be your insulation. One of the primary ones is ceramic fiber. We put out a video showing you how to rigidize that, and that's something you have to do before you use the ceramic fiber blanket. Another popular one is bricks. That's something that we use for our forge because it doesn't have the issues of ceramic fiber. There's a lot of different choices in bricks. I personally use the Morgan K26 brick because I find it to be the most durable for the things we use and do. There's also castable refractories, which are also great. It just all depends on how you use them. Something I do see a lot of guys out there doing is they will get a refractory cement or refractory mortar that is meant to hold together bricks. It is not meant to be an insulating. The standard refractories out there are Castellite 30 is a great one, so is Mizu Plus. They're both rated to 3,000 degrees and will do you for everything you need. There's a ton of other different ones out there. Try them. But these Rutland things that say rated up to 2200 Rutland that you're getting at the typical big box store are not an insulating refractory, okay? They're not going to work for what you want. Now, as far as when you pick your insulating refractory, one of the things you need to determine is the size of your the size of your chamber. The size of your chamber is going to determine a lot of different things. It's going to determine what kind of fuel source you need. It's going to determine everything about the forge. Typical forge is going to be about 4x4 with at least 8 inches in length. You're going to need that to do most ornamental work. You can get away a lot smaller if all you're doing is blades. The next thing is going to be the work face. Now there's a lot of different things that you can use for the work face. Some people use the ceramic blanket itself. I do not recommend doing that. If any kind of flux hits that blanket, it will dissolve. Same goes with the Morgan K26 bricks. If flux hit it, they are dead. So you want something that can withstand flux and can take a beating. Refractories are an excellent thing for this. Castellite 30, again, is great. You also end up with things like ITC 100, Matricoat, Plistex. As far as those go, ITC 100 is an amazing product, but it will rub off. Matricoat and Plistex will stick around and work more for the kind of things a typical blacksmith is going to do. ITC 100 is more for production level. It's high zirconium. It has a great refractory, but it will rub off. If you need your forge to get hot, use it. It will work. The other thing you can do is put it on and then put a thin layer of refractory over top, because that refractory won't rub away. and the ITC 100 or zirconium kiln wash will re-radiate that heat up. The last thing is your fuel source. Either you're going to be using naturally aspirated forced air, ribbon burners. There's a lot of choices. General rule of thumb, I use a 3/4 inch naturally aspirated burner. If a burner is properly tuned, a 3/4 inch burner will take 350 cubic inches to forge welding temperature. So you see a lot of these forges today that when you break down the math, they only have 300 or 400 cubic inches, but they're 2 or 3 burners. All you're doing is wasting fuel. There's no need for that. Build your forge for what you need and build it to work for you. 350 inches on a 3/4 NA burner will still reach forge welding temperatures without any kind of problems if you build the forge right. All right, our next videos we're going to start going over and actually building a forge and showing you how to do that. I believe the first one we're going to make is going to be a ceramic fiber blanket with a refractory coating over top, like most of the typical forges that you can get at entry level. All right, thanks for watching, guys. Have a great day, and we'll see you next time.